integrals, derivatives, series and sequences.
McLaren, Leibniz. I have a D in your class. Please give us an A on this.
P-series test. Integral test.
Taylor polynomials. The hospital's rule. Limits.
Very exciting stuff today. We got the integral test. If f, a function, is positive, continuous, and decreasing for all values of x from 1 to infinity, and a sub n is equal to f of x, then the series from 1 to infinity of a sub n and the integral from 1 to infinity of f of x dx either both converge or diverge depending on what you get when you solve this integral.
Mr. Ostrowitz, can you teach me how to do the integral test?
Of course. Now look, here's an example. We have the series from 0 to infinity of 2 over 3 plus 5n. Now, since we know that it's continuous, positive, and decreasing, we can use the integral test to figure out if it's converging or diverging. Do you get that?
Oh, yes.
Okay. So, we use that a sub n equals f of x. So therefore, f of x equals 2 over 3 plus 5x. Now, using the integral test, the integral from 0 to infinity of 2 over 3 plus 5x dx. Now to solve that, we have to find the limit. So the limit from b to infinity of 0 to b of 2 over 3 plus 5x dx. Now, finding this limit, we can solve that. The limit from b to infinity equals 2 over 5, the natural log of 3 plus 5x from 0 to b. Solving this limit, 2 over 5x, plugging in all these numbers, we find that the limit from b to infinity, 2 over 5 natural log of 3 plus 5b minus 2 over 5 natural log of 3 equals infinity. So, therefore, since the integral from 0 to infinity of f of x dx equals infinity, it diverges, then the series from 0 to infinity of a sub n also diverges. You got it?
I got it.
So today I will be teaching you an example of the integral test.
Ooh, interesting.
So we have a series from 2 to infinity of 1 over 2n plus 7 cubed. And since it's continuous, decreasing, and positive, we know to use the integral test. So we do a sub n equals f of x, and that means f of x equals 1 over 2x plus 7 cubed. And then we find the integral from 2 to infinity of 1 over 2x plus 7 cubed dx. In order to find that integral, we gotta push it. So we do the limit as b approaches infinity of the integral from 2 to b of 1 over 2x plus 7 cubed dx. And then using u substitution and integration, we get the limit as b approaches infinity of negative 1/4 times 1 over 2x plus 7 squared from 2 to b. So then once we plug in 2 to b, we get this, and then when we find the limit as b approaches infinity of all of this, we get 1 over 484. And therefore, since the limit from 2 to infinity of f of x dx equals 1 over 484, which converges, then the series from 2 to infinity of a sub n also converges by the integral test.
Wow,
Got
thank
it?
you. Alright, welcome class. Next topic, the root test. Okay, so given that we have a series, the sum of a sub n, what we're going to do is we're going to put it into this format, which is the limit as n approaches infinity of the nth root, the root test, of the nth root of the absolute value of a sub n. Now after we do that, we're going to see that it fits under one of these three conditions. Well, what are these conditions? Let's find out. So the first condition, if we put it into the format and it becomes where the limit is less than 1, boom, numero uno. The series, the sum of a sub n converges absolutely. And if it converges absolutely, then it converges, of course. 2, the sum of a sub n diverges if the limit as n approaches infinity of the nth root of the absolute value of a sub n is either greater than 1 or infinity. Which is easy to remember, because infinity is greater than 1. Number 3, the root test is inconclusive if the limit as n approaches infinity of the nth root of the absolute value of a sub n equals 1. There you go, class.
Professor, what's that behind you?
Oh, those are Paul's favorite drinks, but let's not worry about that right
Okay.
now.
I will.
It is math time.
Math time.
Okay, so listen, crazy stuff. If you have a series from 1 to infinity of 3n plus 1 over 4 minus 2n all to the 2n power, we know that we're going to use the root test because we see how it's to a power. It's complicated stuff, but I got you. So we're going to put it in the format of the limit as n approaches infinity of the nth root of the absolute value of 3n plus 1 over 4 minus 2n to the 2nth power. So when you find the limit of all of that format, you get 9/4, which is greater than 1. So, since the limit from n to infinity of the nth root of the absolute value of a sub n is greater than 1, then the series diverges by the root test. Hashtag bunculus.
Can we put some butter on them taters?
Get out of here. Okay, back to math. Okay, so our second and final example before our class ends today. We're gonna have the example of the sum from n equals 0 to infinity of n to the power of 1 minus 3n over 4 to the power of 2n. Now, since both the n and the 4 are to the power of an n, what do we do, class?
The root test.
The root test!
The root test.
Of course! So we're gonna put in our little format, the limit as n approaches infinity of this nth root of the absolute value of n to the power of 1 minus 3n over 4 to the power of 2n. So now, after that, we're gonna change how it looks like, change the format. Same exact thing, except instead of having the actual square root, we're just gonna put it all to the power of 1 over n. Same thing. Next, we're gonna actually do it, use the power. So we get the limit as n approaches infinity of the absolute value of n to the power of 1 over n minus 3 all over 4 squared. Notice how the 4 no longer is to the nth power. Finally, we're going to have the limit as n approaches infinity of the absolute value of n to the power of 1 over n times n to the power of negative 3 all over 4 squared, which gives you 1 times 0 over 16. Anything times 0 or divided by 0 is?
15.
Wrong! 0! Come on.
0. I knew that.
So, since the limit as n approaches infinity of the nth root of the absolute value of a sub n equals 0, this series converges absolutely by the root test. And since it converges absolutely, it converges. Well, that's it for today.